Okay, Hooke's law. Okay, just to recap where we left off, Hooke's law states that the force, okay, is directly proportional to the extension with one condition. What is that condition? What is the condition of Hooke's law?
Melebihi elastic limit.
Okay, so cannot exceed the elastic limit. Okay, what happens if the force exceeds the elastic limit? If the force, okay, exceeds the elastic limit, what happens?
Overstretch.
Over this one, okay, what else?
Graph dia dah bukan directly proportional.
Okay, graph tidak directly proportional, so the graph becomes straight and then become bengkok. Okay, one more thing. When something is overstretched now, what happens to it?
It will lose its elasticity.
Very good. Okay, it will lose its astaga. It will lose its elasticity. Okay, and elasticity is the ability for it to go back to its original shape. So it's very important, you know. Okay, this whole subtopic is about bolehkah ini benda menampung this daya. Okay, bila kita cakap dia boleh menampung daya means kalau dia boleh tampung means bila kita keluarkan itu daya, it can go back to its original shape. Okay, that is the basic function of elasticity. Okay, two formulas, okay, that have to do with Hooke's law. The first is F equals to Kx. Okay, what is K representing? K represents what?
Gradient.
Okay, gradient kalau dia adalah graph. Okay, very good. Okay, K represents the spring constant. Okay, now let's relate once again the spring constant to the stiffness of the spring. Can somebody tell me the relationship between the spring constant and the stiffness of the spring?
The bigger the spring constant, the bigger the stiffness.
Okay, the bigger the stiffness. The bigger the spring constant, the harder it is lah, lebih keras. Okay, but, and this is something that we're going to talk in a little while lah. When something is stiff, okay, when something is stiff, it is less elastic. This is a very strange thing to think about, okay, but it is true, you know. Bila dia punya spring constant sangat tinggi, okay, that means you need a lot of effort in order to make it stretch lah, okay, by 1 meter. But the problem is, it is also less elastic. Dia senang untuk terkeluar daripada dia punya elasticity. Okay, dia senang untuk tidak kembali kepada keadaan asal. Okay, and it's hard for us to think because we always think that, oh, okay, spring yang keras means dia boleh tahan lama. It's not true, no, actually. Spring yang keras yang paling senang untuk rosak. Okay, because dia sangat keras lah. No, it cannot take that much tension. It can take, it can take a lot of force, but it is less elastic. Okay, dia susah untuk kembali kepada keadaan asal after dia punya elastic limit. Okay, so this is something that we need to think about now and we need to really remember, because a lot of people, they think, okay, kalau spring constant tinggi, stiffness tinggi means elasticity pun tinggi. Salah. Okay, when the spring is very stiff, okay, the elasticity dia akan berkurang, and this is very important. So the stiffness, okay, and the elasticity, okay, is inversely proportional. When something is stiffer, the elasticity dia akan berkurang. Senang untuk kita kasih pecahkan itu spring, okay, in a sense lah. So a soft spring lah, dia punya spring constant sangat kecil, dia sangat tidak stiff lah. Okay, very easy to stretch. Okay, very easy to stretch means it is more elastic. Because very easy to stretch means it's very easy to come back to its original position. When something is less elastic, atau dia punya stiffness sangat besar kan, very hard to stretch and very hard to go back to its original shape after you take out the force. Okay, this is new, this is new and sometimes a bit mind-blowing lah, macam, oh really saya tidak terfikir pun macam tu. Okay, but this is something that we need to remember, especially in today's class. When the stiffness increases, the elasticity decreases. Very, very important thing. So today, second formula. Besides the force formula, what is the second formula that we talk about that is involved in Hooke's law?
Elastic potential energy.
Okay, elastic potential energy. I'm just going to write EPE over here. Give me the two formulas for elastic potential energy.
1 over 2 Fx.
Okay, and the other one?
1 over 2 kx square.
1 over 2 kx squared. Okay, now it is important to note, and I think Jennifer was the one that spoke to me about this yesterday. Okay, it's very important to note that because we're talking about energy, okay, and because we're talking about force, the x must be in meters. Okay, this is a non-negotiable fact. Okay, it must be in meters unless unless you are willing to use the K, okay, unless you're willing to use the K in the unit of Newton per centimeter. Okay, if you're willing to use the K in Newton per centimeter, then you can use X in centimeters. But for all intents and purposes, actually I prefer that your K and your X must use meter lah. Okay, try not to use centimeter. But we also have to be flexible. Sometimes it depends on the question. Okay, question give Newton per centimeter, then you use centimeter. If question give Newton per meter, then kamu guna X di dalam meter. So be careful. Okay, please write this note down there. Be careful of the unit of K. Because the unit of K will tell you which X you pakai. You want to use centimeter ka, meter ka, begitu. Okay, and yesterday we looked at this question and I said that when the K, when the K is bigger, okay, we saw this, when the K is bigger, the spring is stiffer lah. Okay, and this is just to recap what we were talking about. Okay, so what does the K mean? So let's say, for example, okay, so in this case, let's say the K is 100 newtons per meter. Okay, the spring constant is 100 newtons per meter. This means that you need 100 newton of force to extend the spring by 1 meter. Okay, that's what it means. I need you to understand what does the value of the K mean. Okay, so in this example, let's say Ka, if let's say K is 200 Newton per meter, means you need 200 Newtons of force to extend the spring for 1 meter. Okay, manakala, if let's say your K is 200 Newton per centimeter, this is even more jialat no, actually. Means 1 centimeter, you need 200 newtons. It's very, very, very high. Okay, you just want to extend for 1 cm only, you need 200 newtons of force. Okay, so just be very careful with this meter and this centimeter. Meter and centimeter just tells you how much you want to extend. Okay, and the number will tell you how much force you need in order to extend by that much. Okay, so this is what we've covered in our previous lesson, which was yesterday. Now today, I want to talk about the factors that affect the value of the spring constant. Okay, the spring constant is given with the letter K lah. So what are the 4 factors? There are 4 factors over here altogether, and it is also written in your notes in page 17. Okay, so the 4 factors are the length of the spring, okay, panjang spring tersebut. Kedua adalah diameter of spring. I want you to take a look at this diameter. This is a bigger diameter, and this is a smaller diameter. Okay, dia punya lingkaran, dia punya coil. Okay, that's the diameter of the spring. The third one is the thickness of the spring wire. Okay, ini adalah tebal, ini adalah nipis. Now, please write a note in there. The thickness of the spring wire, okay, sometimes is also known as the thickness of the spring wire. Sometimes is also known as the diameter. Sorry, my mistake. Sometimes it's also known as the cross sectional area of the spring wire. Okay, the cross-sectional area of the spring wire. Sama ada dia punya lebar adalah besar atau dia punya lebar adalah kecil. If the wire is big, okay, then the cross-sectional area is big. It's thicker spring wire. Okay, so certain books now will give you this word. Ada setengah buku akan cakap thickness. Our note say thickness lah, bahkan D ya. D is thickness. Tapi some books now will say cross-sectional area. But it means the same thing. Okay, and then lastly is the type of spring. Ada banyak jenis spring di dunia ini. Sometimes you have steel spring, sometimes you have copper spring. Okay, so we want to see, and actually this is an experiment lah, but we have no time to do the experiment today. We want to see how does the length of the spring affect the value of the spring constant. Now, if you remember from your graph, if we draw the graph of F against X, how do I find the value of the spring constant? If I draw the value of F against X, how do I find the value of the spring constant?
Using gradient.
Okay, we calculate using the gradient. Okay, so you have this, then you calculate the gradient, and you find the value of the spring constant. So that means, let's say if I have two graphs, okay, and let's say the first graph is like this, okay, and then the second graph, sorry, okay, the second graph is like this. Let's say this is spring A, this is spring B, and then the third graph, oh dear, okay, the third graph is like this, and this is spring C. Okay, of course, this is F against X lah. Okay, from this graph, tell me which spring has the biggest spring constant, A, B, or C?
C.
Okay, C has the biggest spring constant sebab the gradient is the biggest. Makin dia ke bawah kan, dia kurang condong lah. So A has the smallest spring constant. Okay, in terms of stiffness, okay, dari segi kekerasan spring, which spring is the most stiff?
A.
A is the most stiff.
C.
Let's take a look. You said that spring constant bigger means stiffness bigger. Oh, that means it's actually C lah. C, the spring constant is bigger, so C is more keras. Don't confuse stiffness with elasticity. Two different things altogether. Okay, and also what I said just now lah. Makin keras itu spring kan, dia punya elasticity makin kurang. Okay, which we will come to in a while. Okay, so first point, let's talk about the length of the spring. Okay, a shorter spring will have a higher spring constant. Okay, higher spring constant means dia keras atau lembut. Dia stiff or less stiff? Higher spring constant. Okay, it will be stiffer. Okay, and it's very easy to see lah. A short spring, kalau spring dia pendek kan, dia memang lebih keras. And so because of that, the elasticity, it is less elastic. Susah untuk spring yang pendek kembali kepada keadaan asal. Okay, berbanding dengan long spring. A long spring has a lower spring constant. That means it is less stiff. Okay, it is less stiff, but it is more elastic. Dia senang untuk dipanjangkan, senang untuk kembali kepada keadaan asal. Okay, dia punya elastic limit lebih tinggi lah. Okay, so this is something that we need to think about lah. Okay, and to really think about this. Less elastic means the elastic limit, okay, is less. Manakala more elastic means dia punya elastic limit, okay, lebih tinggi. You can put more force on a long spring. Okay, you can put more force on a long spring, and it can still come back to its original shape. But for a shorter spring, it is harder. Okay, dia lebih keras. Tetapi, if you put more force, it may be harder for the shorter spring to come back to its original position. Okay, so all this is berkaitan. Okay, when the spring constant is higher, it is stiffer. But the elasticity is less. and therefore the elastic limit is less. You can put only so much force kan, then lepas tu dia akan hilang dia punya elasticity because it is stiffer. Okay, stiffer means dia kurang flexible lah. When something is kurang flexible kan susah ni. Kau tidak boleh terlampau memberi dia banyak tekanan. Okay, macam pelajar jugalah. Okay, when we are not so flexible kan, we are very easily stressed. Okay, so there's a little bit also be stressed already. But somebody who is very flexible kan, okay, they're not very stiff lah, you know, they're very relaxed, very easygoing kan. You can put a lot of things on that person and he'll be like, okay, bisa aja, macam tu. Okay, so this relationship is very important. So the first one is the bigger the length of the spring. Okay, tell me the spring constant how? The bigger the length of the spring?
Lower.
The low.
Okay, the lower the spring constant. Okay, now, so this one memerlukan kita untuk satu menghayati dan kedua untuk mengingatlah what does lower spring constant mean? Lower spring constant means less stiff, less stiff, and dia punya kawan adalah more elastic. Okay, more elastic means dia punya elastic limit adalah higher. Okay, so there's all these things, there's all this information that comes by just saying that dia punya spring constant adalah lebih kecil. Okay, so follow that direction. Dia macam saya cakap lah, macam saya cakap dulu, kalau constant velocity, zero acceleration. Increasing velocity, acceleration, constant acceleration. This kind of pairing always goes together. Something that is less spring constant is less stiff and more elastic. Okay, so set it in your mind. Okay, ini dia punya urutan. Okay, so this is the first one. The bigger the length of the spring, the smaller the spring constant. Dia lebih lembik, dia lebih lembut. Okay, dia tidak terlalu keras. Secondly, the diameter of the spring. Okay, spring yang kecil dan spring yang besar. What do you think? Which one is harder? The bigger spring or the smaller spring?
Bigger.
Bigger is harder. Bigger is harder. Okay. Bigger is harder. So you are saying that the larger diameter, the K is bigger. K is bigger means what? In terms of elasticity? Sorry?
High.
Less elastic.
Okay, it should be less elastic lah. Okay, ini adalah kamu punya jangkaan lah. Let's figure this out first. Kita buat dulu, nanti kita tengok jawapan lah. So you're saying the smaller diameter, spring yang lebih nipis, no not nipis, spring yang lebih kecil lah, dia punya lubang lebih kecil, is less keras and more elastic. Okay, kita jangkakan dulu then we see what happens. Okay, what about the thickness of the spring? Spring yang tebal dan spring yang halus. Kalau thick spring
is more spring constant.
Bigger spring constant, lebih keras. Okay, so in terms of elasticity,
They are less elastic.
okay, less elastic, this is more elastic. Okay, let's take a look. Another one, steel and copper. Steel is besi Okay, copper is cuprum, I think, dalam bahasa Melayu. Yeah. What do you think? Which is a bigger spring constant kalau antara steel dan copper?
Steel.
Okay. Ini kau yang cakap lah. Okay, so steel is bigger, copper you think is smaller. So because of that, in terms of the elasticity, steel is
Less.
less elastic, copper is more elastic. Okay, you know what? Let's do one more kind of metal lah. Okay, and this is a more common metal actually. Selain daripada steel, which is besi, and copper, which is in cuprum, there's another kind of spring which actually is even smaller. Dia punya spring constant, which is the aluminium spring. Okay, do you guys know aluminium? Like macam our tin can lah. Kalau kita punya minuman tin kan kebanyakannya adalah aluminium. Okay, so let's say you compare to copper lah. Which is less stiff? If you have a copper spring or aluminium spring, mana yang kurang dia punya K?
Aluminium is less.
Aluminium.
Aluminium, you're saying that aluminium is way less lah, okay, compared to copper. Okay, but let's take a look. So first of all, diameter of spring. So you're saying that the smaller the diameter, that the higher the spring constant. Okay, this is hard for us to imagine. When the diameter is smaller, actually dia adalah lebih keras. Okay, manakala dia punya elastic adalah kurang. Okay, am I getting this right? Hold on. Diameter of spring is higher when the diameter, yeah. Okay, actually it's in your notes, but never mind, since you're looking at the screen. Okay, so this is something that we have to remember, because antara semua ini kan, diameter of spring yang selalu orang salah. A lot of people think that the bigger spring, okay, yang lubangnya besar bahkan, okay, dia adalah lebih keras. Okay, but that's not true. Okay, the smaller the hole, okay, kalau dia punya spring adalah sangat kecil, assuming that both the springs have the same thickness lah, dia punya wire jenis sama, dia punya ketebalan sama, cuma bezanya adalah dia punya lubang spring itu. Okay, when the spring has a smaller hole, okay, it is actually harder, stiffer, okay, more stiff, dia lebih keras. So the spring constant is higher, but the problem is it is less elastic. Okay, so ini minta maaf lah, kalian telah silap. Okay, the larger diameter has a lower spring constant. Okay, and therefore it is more elastic. Sebab dia besar, dia besar, and so dia senang untuk dipanjangkan lah. Okay, so far for the diameter of spring, unfortunately your answers are not correct lah. Okay, so please take note of this. Secondly, you say the thicker spring has a bigger K, manakala the fine spring has a smaller K. Bigger K means dia lebih keras, smaller K means dia kurang keras. So, correct. Okay, so the thicker spring has a higher spring constant. Ini biasalah. Okay, manakala dia less elastic. Ini normal. Okay, fine spring yang halus ini, dia adalah lebih lembut, so the K will be lower. And then because the K is lower, it is more elastic. Okay, type of spring material, you say that steel spring has a bigger K, means dia lebih keras. Correct. Okay, so the steel spring has a higher spring constant, but it is less elastic. Okay, senang untuk dia melebihi elastic limit. Copper spring obviously is lower, and therefore it is more elastic. Okay, aluminium is even lower lah. Okay, so notice this, everybody. Notice that the one where a lot of people will be salah is this one. Ini adalah antara tempat di mana ramai pelajar akan silap di sini. Because they think that, oh, okay, kalau dia smaller diameter kan, dia akan lebih lembut. It's not true. Okay, the smaller the hole actually is harder. Okay, it is more stiff lah. Okay, diameter spring yang sangat besar kan, dia senang betul untuk dipanjangkan. Okay, it's easy to extend the spring. Okay, so ini adalah perkara yang saya mau kamu take notice of lah. Okay, because this is one of those things that a lot of students will get this wrong. Okay, so this one we've done, but can somebody just tell me what is the relationship between the spring constant and the stiffness of the spring?
The bigger the stiffness, the bigger the spring constant.
Really? The bigger the stiffness, the bigger the spring constant. So stiffness yang dulu.
The bigger the
Stiffness.
spring constant, the bigger the stiffness.
Really?
Sir!
Maybe this is also why nobody likes to answer my questions, because saya membuat kamu rasa, betul kan ini? Mana yang mempengaruhi mana? Spring constant affects the stiffness or the stiffness affects the spring constant?
Stiffness.
The spring
Stiffness,
constant affect the stiffness.
Oh, spring constant affect the stiffness. Okay, the higher the spring constant, the more stiffer the spring. Okay, spring constant yang constant, so it must come first. Okay, kekerasan spring itu bergantung kepada the spring constant. Okay, second relationship between the spring constant and the elasticity.
The more the stiff constant, the less the elasticity.
Spring constant, bukan stiff constant, but okay. All right, the higher the spring constant, the lower the elasticity of the spring. And just to remind you, lower elasticity, okay, means, okay, the elastic limit, okay, is lower. Okay, elastic limit lower means it is harder to make it extend. Okay, harder to make it extend, but easier to make it not elastic. Okay, means once you overextend a little bit, terus dia tidak boleh kembali kepada keadaan asal sudah. Okay, so number 3, let's complete this. The longer the spring, the blah 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 elastic, and blah 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 the spring constant. Astaga. Okay, anybody?
More elastic.
The more elastic and something the spring constant.
Lower.
Spring
The
lower.
lower.
Lower kali. Oh, the lower. Okay, the lower the spring constant. Okay. Okay, so it is a soft spring. Okay, spring yang panjang adalah spring yang lembut lah. Okay, not so keras. Second, the larger the diameter of the spring, the elasticity becomes. Ini yang selalu silap.
More.
The larger the diameter, the elasticity becomes higher, and the spring constant
Lower.
lower. Okay, so remember that is terbalik lah. So this is a lembut spring. Sorry, it's a soft spring lah. Okay, so soft spring is long, the diameter is big. Okay, thirdly, the thicker the diameter of the wire. Okay, kalau wire itu lebih tebal, the elasticity will be
Lower.
lower, and the spring constant
Higher.
higher. Okay, is this spring hard or soft?
Hard.
Hard.
Okay, it'll be a hard, stiffer lah. Actually, we shouldn't say hard lah, we should say stiffer. Okay, lastly, the spring that is made from steel is
Less.
Elastic.
less
Lower.
elastic, but lower ka? Lower spring constant.
Less. High spring constant.
Oh dear. Okay, higher spring constant. So dari segi soft or stiff, is it a soft
Stiff.
spring or stiffer spring? Okay, it is a stiffer spring. Okay, so think about this. If you want to get a soft spring, okay, let's summarize this. If you want to get a soft spring, okay, apa ciri-ciri soft spring? It must be long. In terms of the diameter, it should be big diameter. Okay. In terms of the thickness, thin or thick wire?
Thin.
Thin.
Thin wire. And of course, you want to use something like copper. Okay. So this is the ciri-ciri of a spring that is soft. A good soft spring. Very long spring, the diameter is big, the wire is thin, and then you use a copper spring. Okay, but if you want a stiff spring, okay, you use a short spring, use a small diameter, okay, use a very thick wire, and then you use, something like steel. So, for example, let's say, the pen that you have, the tic-tac pen, kan? Okay, so essentially, the tic-tac pen is actually a long spring, that's why it's soft. Maybe not so big in diameter, okay, it's pretty small in diameter, but it is definitely a thin spring. Okay, that's why it's very easy. That's why your pen can masuk keluar dengan sangat senang. Okay, so, and then of course, one example of a hard spring, where do we see hard springs? Can anybody think about a situation where we will have a hard or stiff spring?
Car suspension.
Okay, car suspension. All right, good. Car suspension. So the car suspension, the spring is actually very short. Of course, not as short as the pen punya spring lah, but it's still short lah, Dia bukan like setinggi dunia tau, but it's a very short spring. But the diameter is actually quite small. Kalau compared to other springs, the diameter is actually very small. Okay, but the most important thing is that the wire is very thick. Okay, the wire is very thick. Okay, so it's a stiffer spring lah. Of course, if I'm not mistaken, the car suspension, the spring is made of steel. Okay, that's why it can tahan more weight. It can tahan more force. Okay, whether kalau macam jalan-jalan ke atau apa kan. But the problem is it is less elastic. Senang untuk dia hilang dia punya elasticity. Okay, so that's why you shouldn't jump inside the car. Okay, like, okay, mari kita jump, or make the car shake for no reason. Okay, because it affects the suspension. And the last thing you want to happen to your car is for the suspension to rosak, because it's very expensive. Okay, so yeah, next time you go into the car, please go into the car gently. Okay, don't just throw your body on the car. Like that. Okay, and then expect the suspension to do the work for you. Okay, after a while, the suspension pun akan mogok. Okay, setiap mau sudah lah. Okay, every time Marcus go in the car kan, terus the kereta pun toing begitu. Okay, not so good lah. Okay, so these are all examples. Another example actually is a mattress. Okay, certain mattresses have springs, and the springs are actually pretty good lah. Okay, they are they are short springs. Okay, with not so big diameter lah. We're not talking like this big diameter. Okay, but they're definitely thick springs. Okay, and why do we want thick spring and short? Because we want it to menampung beban orang lah. Okay, the weight of the person, so that the spring can be the mattress can become springy lah. Imagine if you use a long spring, okay, or imagine if you use one that has a very big diameter. Okay, this is still considered small lah. Imagine if you replace this four with one spring like this. Okay, it's going to lose its stiffness after a while. Dia akan jadi sangat lembik. So dia punya spring sangat besar. Okay, the diameter of the spring sangat besar. So we want small diameters but many springs. Okay, that's good lah, so that it is more stiff. Okay, of course this is the one that you mentioned just now, the suspension di kereta dan juga di motor. Take a look at the thickness of the spring, people. Okay, it's very thick. Okay, sangat tebal. Same thing goes with the baby. Okay, and this is what I want to talk about next lah. Okay, the next thing I want to talk about is this kind of arrangement. Okay, so we put the baby over here. Okay, and then dia akan tidur lah, zag. Okay, and then this one akan menjadi the buayan. Okay, you go up and down. So it will extend, compress, extend, compress, extend, compress. Okay, but notice that now there is a certain arrangement over here that is very interesting lah. It's not just dia bukan sekadar one spring sahaja, then terus buayan tau. It is actually many springs. Okay, and this is also another factor which we have to consider. Okay, kita kena pertimbangkan the arrangement of the spring. What is the difference between this kind of arrangement? Okay, let's say if I give you 3 springs lah, okay, and I ask you to put a beban over here. If I arrange it like this, or if I arrange it like this. Okay, tell me which is more elastic. The one that arranged 3 in a row or one after another?
One after
3 in a
another.
row.
One after another, 3 in a row. I heard both answers. Which one is more elastic?
One
After another.
Okay, the one after, the second one. The one after another is more elastic because it is less stiff. Okay, dan ini sesuai untuk apa tahu? Let's say you want to go bungee jumping, right? Okay, this is the best arrangement lah, because you don't want it to be so keras, So imagine if you go bungee jumping and then the person who put the spring on you, put the three springs in a row like this, Kau belum lagi sampai di bawah kan, kau sudah tertarik ke atas, and it's a very horrendous feeling lah, because the spring is so keras. This arrangement is less elastic, but it is stiffer, which is not good for bungee jumping. Bungee jumping kan, you want it to toing betul-betul bah. And you want it to extend properly so that you get the full experience of bungee jumping. Imagine if you bungee jump with this kind of arrangement, right? Kamu lompat saja kan, terus dia kau akan naik balik. Okay, tiada masa untuk kamu extend sebab dia sangat keras. Okay, so there are good things about this kind of arrangement yang saya cakap one after another, and there are also good things about this kind of arrangement, which is 3 in a row. I mean, in a row lah. Okay, so for example, in the case of the baby, we want it to be in a row because imagine if you imagine if you put the baby on here lah. Okay, dia akan sentiasa terhantuk kepalanya di atas lantai because the spring will be over extending. Okay, and this brings me to the arrangement of springs. There are 2 kinds of arrangements. Okay, macam saya cakap, there's in a row macam ni atau one after another. So, the one after another is called in series. Okay, so dia adalah one after another. Satu, macam tu. Manakala, the arrangement in parallel is in a row. Okay, semua dalam satu baris. So 2 springs that are one after another is called in series arrangement. Tetapi 2 springs, 2 or more springs that are arranged in a row is called in parallel. And just now kamu sudah cakap, okay, the spring constant and the stiffness of the spring for parallel and for in series. What is it? Anybody? Is it
Spring
higher, lower?
constant series is lower.
Okay, spring constant series is lower, so the stiffness is also lower. Manakala spring constant for parallel is higher, so the stiffness of the spring is higher. Cuma dia less elastic. Okay, don't forget that lah. So, in terms of the load stretching, the stretching force applied on the springs acts on each spring. Okay, I will talk about this a little bit later. Manakala, kalau parallel, the stretching force is divided equally among the springs. This is the key word that we want to talk about. Kalau parallel, okay, and then this is the key word for in series. Okay, I will talk about this in a little while. Okay, the tension on each spring. So for in this case, okay, if let's say your beban is F, okay, let's say your weight is F, each spring in the parallel will only experience half F. Manakala, if this is in series, each spring akan merasai the F tersebut. Dia tidak kena bahagi. Okay, dia setiap satu akan mengalami the same force. Okay, seperti kalau ada satu sahajalah. Okay, so the extension of the spring, okay, will be X. Manakala in parallel, it will be half X. Okay, sebab hanya setengah saja daripada force yang dia alami. So the extension will be half of the extension for one force lah. Okay, the total expansion of the spring, okay, jumlah pemanjangan adalah, kalau spring ini pemanjangan X, kalau spring ini pemanjangan X, so the total expansion will be 2 times X. Manakala for parallel, the total expansion will be only half X. Sebab dua X itu akan dibahagi sama rata. Astaga, half X. Okay, spring constant, I already said, it will be the spring constant, okay, for the in series, it will be half K. Okay, as you said just now, it will be less stiff. Okay, manakala the spring constant for this one will be 2K, it is stiffer over here. Okay, less stiff on the series, parallel is more stiff. Okay, the total extension of spring will be N times X. Nanti saya cakap pasal ni lah. Okay, manakala the total expansion of spring, if use N springs, is just X only on its own. Okay, so these notes actually are not in your this one, and I think they are in your textbook. Is this in your textbook? Can somebody check your textbook? Is this comparison between in series and parallel in the textbook? Adakah?
Ada
Page?
Page 30.
30 and 31.
Okay, page 30 and 31. So, okay, refer to that lah. Refer to that. That comparison is very important. But basically, it's like this lah. In series, the extension is a lot more. Okay, sebab in series, setiap satu spring akan mengalami the extension. Tetapi parallel lah is seperti berat sama dipikul, ringan sama dijinjing. Okay, so every spring akan mengambil bahagian dalam one extension. Okay, in series every spring akan one extension. Tetapi parallel, every spring bahagi one extension. Okay, so let me give you the, let's say this situation. Okay, so the original length of a spring is 5 cm. Okay, so if I draw this out now, oh dear, hold on. Okay, so the original length of the spring, dia ada beban. Okay, so the whole thing over here is 5 cm. Okay, when you put a mass of 20 grams, the length of the spring is extended to 7 cm. Okay, so kalau saya letak 20 grams, the spring akan menjadi 7 cm. Okay, my question is, how much is the extension? How much is the extension? Berapa dia punya pemanjangan?
2 cm.
Okay, it will be, so the extension, astaga, extension is 2 cm. So, the question is, the extension of the spring with a load of 40 grams. Okay, so how will we do this is, okay, so this is how 20 grams will give you 2 cm extension. People remember, extension is the new length minus the original length. Okay, so 40 grams will be like this. Okay, how do we find this 40 grams? So the easiest way to do this is to use ratio. Okay, we use a very basic ratio. So kalau 20 gram akan menghasilkan 2 cm, 40 grams akan menghasilkan X cm. Okay, and you count, you will get 4 cm. Okay, so the good news about this particular kind of question is, you don't really have to worry about centimeter ka, gram ka, apa-apa. Sebab kamu pakai nisbah sahaja. So the unit will cancel each other out. Okay, so that's how we will do this. The length of the spring with a load of 60 gram. Okay, so we use the same method. Okay, X over 60. Oh, you know what? I'm just going to show you. Same thing lah. If 20 grams is 2 cm, 60 grams is how much is the extension? So you use the same thing as the, use the same thing as the ratio just now. Okay, X over 60, because that's what we want, equals to 2 over 20. We use ratio to do this. Okay, so you find that X equals to 6 cm. But you haven't answered the question. The question is not asking for the extension. The question is asking for the length of the spring. So you need to do one extra step, which is to, astaga, tidak siap pula ni. You have to 6 plus, what's the original length? The length is 5 cm. Okay, which will be 11 cm. So the length of the spring, okay, so please, when you're answering questions to do with Hooke's law, differentiate between these two words. Extension, dalam bahasa Melayu dipanggil pemanjangan, dan length. Okay, length is just panjang itu. Sama ada dia panjang sebelum pemanjangan atau panjang selepas pemanjangan, bergantung kepada soalan. Okay, but in our formula, F equals to Kx. Okay, this X refers to the extension, not the length. Okay, let me remind you once again. X refers to the extension, berapa banyak dia memanjang. Bukan berapa panjang selepas dia dipanjangkan. Okay, very careful with this, because this is the another common mistake that a lot of students make. Terus dia orang cakap, susah ni soalan. Padahal dia sendiri tidak faham beza antara extension and length. Okay, so please know the difference. Very big difference. Okay, bagaikan langit dan bumi. Okay, so a spring with an original length of 50 millimeters extends by 6 millimeters when stretched by a force of 12 newtons. So this is interesting lah. Calculate the spring constant of the spring. Can you calculate this for me, please? What's the formula for the spring constant? Kalau saya diberi these two, K equals to
F
Okay.
over X.
F over X.
okay, F over X, except that, and I'm not sure whether they're going to do this for this, kita punya X sepatutnya
Meter.
dalam meter. This is in millimeter, people. So please change millimeter to meter. Okay, I'm not actually sure whether they're going to use this, but let's just try and see lah. Okay, so use 6 now, people, because 6 is the extension, not the length. Okay, calculate and tell me, please, what is the value of the spring constant? K equals to 2000
Newton over M.
okay, Newton per meter. Okay, 2000 Newton per meter, but I'm not actually sure whether dia punya jawapan adalah begitulah, but let me check lah. Oh, okay, so dia pakai 2 Newton per millimeter. Okay, can lah, also can, but if you use 2000 also doesn't, no problem. But this is an important thing. Dia cakap, whenever you put a 12 Newton force, it will extend by 6 millimeters. Because all 3 cases, dia adalah 12 newtons. Okay? So, let us determine for every arrangement A, arrangement B, arrangement C, okay, what is the force on every spring? Tegangan dalam setiap spring, means every spring akan mengalami apa. Okay, first tell me, arrangement A is what kind of arrangement? Series or parallel?
Series.
Okay, this is a series arrangement. Arrangement B? Parallel. Okay, so why don't you take a guess on the arrangement C?
Triple parallel series.
Gabungan.
Oh yeah, okay. It's probably a combined arrangement lah. Okay, it's a very extra arrangement lah. I don't really know anybody who arranges springs like that, but yeah, it's kind of very extra lah. Okay, so the tension on each spring, for this arrangement, how much would the tension be? Sorry, how much would the force be on each spring? Setiap spring akan mengalami 12 ke kena bahagi 2?
12.
Dia akan mengalami 12. P will be 12, Q will also be 12. What about R and S?
Divide by 2.
Divide by 2. So they will get 6 each lah. Okay, so each of these springs only experiences 6 newtons because berat sama dipikul, ringan sama dijinjing. Okay, you can think of the series arrangement like tarik tali lah. Dalam tarik tali kan actually no such thing as berat sama dipikul. Semua kena tarik. Kalau satu orang tidak tarik terus hancur. Kan? Siapa yang ada pengalaman? Okay, anyway, what about this? TUVW. This is interesting.
4, 4, 4, 12.
Oh, excellent. Okay, TUV will experience 4 each. Okay, because they are in parallel. But together, they will experience 12. Manakala W alone, because he is in series, okay, will experience 12. Okay, that's very good. Was that Elijah that answered this just now?
Capik.
Okay, so extension on every spring. Tell me the extension on P and Q, please.
6, 6.
It will be 6 and 6 because they each experience 12 newtons. What about R and S? If they each experience only 6 newtons, what is their extension?
3, 3.
3, 3.
Okay, it will be 3, 3. Now tell me T, U, V, and W. Obviously, W, everybody knows that. W will be 6 lah. But what about T, U, and V?
2, 2, 2,
2.
2, 2, 2, right kan? Okay, so T will be 2, U will be 2, V will be 2 because they each have to extend only, 6. Okay, yeah, okay, and then manakala W will be 6 lah, 6 millimeters. Okay, so you notice that when they share the burden, when they share the load, bila beban itu dikongsi, the pemanjangan also akan dikongsi sama rata. Okay, that is for parallel arrangement. But for series arrangement, okay, when each of them have to extend on its own kan, so it will become longer lah. So, what is the total extension for the spring, the system? So 6 plus 6 will give you 12. Okay, what about in B? What is the total extension?
3.
Yeah, okay. It will be 3. You cannot say 3 plus 3 is 6, because this one extend 3, this one also extend 3. But actually, if you look at it holistically, they all also only extend 3 only. So be very careful if parallel arrangement kan, one spring equals to all springs. So very, very easy. What about the total extension of system C?
8.
Okay, it will be 8. This time I recognize this is definitely Shafiq Iqbal's voice. Okay, so last question. What is the total length of the arrangement? Remember, the original length is 50 millimeters. So once you take into account the jumlah pemanjangan, how much is the total length for A?
62.
Sure, no, Mordecai.
112.
112.
Okay, it will be 112. Of course, there's 2 springs, bro. Okay, there are 2 springs. Each spring is 6, 6. So 6 plus 6 plus 50 plus 50 lah. Or 50 plus 50 plus 12 pun boleh. Okay, what about arrangement B? What is the total length now?
53.
Okay, it will be 53 because one spring is 50, only extends by 3, so it becomes 53. Baiklah, what about C?
108.
108. Wow, okay. Iqbal is on fire. Selepas saya panggil dia Elijah kan, terus dia, okay, saya mesti bertekad untuk memberi jawapan yang betul dalam suara yang betul. Okay, but all this of course is in millimeters lah. Don't forget lah. Okay, it's in millimeters. Okay. Let me see. How many examples do I have? My goodness, so many examples. Okay. Let me try to finish all these examples and then we will call it a day lah. Okay, so this is the same thing. So 13 centimeters will give you 6 newtons. The original length of the spring is 10 centimeters. Okay, when it is stretched by a force of 6 newtons, it will extend up to 13. What is the spring constant? Anybody? Spring constant? Okay, spring constant is 2 unit, please.
Newton per cm.
Okay, Newton per cm. All right, because you use x in cm lah. So not necessarily to change it to meter, especially if everything is going to be in centimeters, kan? Don't need to change lah. Okay, so 2 identical springs are connected in series. What is the total length of the spring if it is stretched by 12 Newton force? Okay, so this is where the K comes in lah. Okay, so if it is 2 springs and it is 12 newtons, we have to consider 1 spring first. Okay, if 6 newtons will give you an extension of 3 cm, 12 newtons will give you what? Extension of?
6.
Extension of 6 cm. But because they are arranged in series, is the extension divided or each of them have their own extension?
Each of them have their own.
Okay, each of them have their own. So what is the total length of the spring? Original is 10. 20.
26.
26 saja.
Centimeter.
26 centimeter. 26 centimeter.
22.
Somebody said 22 cm.
32. 32.
Or 32. Somebody said 32 cm. Any other answers? Remember, series. Okay. So actually, yeah, the answer is 32 because each spring will extend 6. They will plus 6 plus 6 because it's in series. Okay, but the original length is 10 lah. 10, so 10 plus 6 will become 16. So 16 times 2 will be 32. Okay, same thing but now in parallel. What is the total length? Since the force is 12, the extension will be 6 lah. Okay, but now what is the total length of this one? The spring system. Dari sini sampai sini. Berapa?
26.
26. Okay. Any other answers?
16.
13.
16,
13.
13.
13,
Okay.
13, yeah.
13.
More people say 13, okay. So it's either 13 or 26 lah. Okay, let's check it out. So one spring, one spring ditarik oleh daya 6 Newton, so the extension is only 3 because it's equally divided. So from here to here is actually just 10 plus 3. Okay, so it's 13 cm. Okay, so it actually depends on what you are thinking right now lah. In my experience, most people are actually confused with this word. What is the total length? Total length means dari dinding sampai ke sini. Berapa dia punya panjang sekarang selepas dia sudah dipanjangkan. That's what it actually means. Bukan panjang ini campur panjang ini ya. It's not that. That's not why. That is not what is meant by the total length lah. I understand the confusion. Okay, but you need to understand that the total length means from the place where the spring starts until the place where the force or the beban starts. Okay, that's the total length. Okay, let's take a look at this situation. Hold on, this situation. Okay, so spring A extends by 2 cm when it is hung with 10 grams of weight. Okay, so the extension is 2 cm for every 10 grams. Spring B extends by 4 cm when it is hung by 10 gram weight. So now you have two different types of springs. Find the total stretch, okay, in each of the spring systems. Okay, let's consider A first lah. Okay, sorry, let's consider this situation first. Oh, no, this situation first, sorry. So this is 20 grams. Okay, how much is A going to extend?
2. Yeah.
4.
Okay,
4
it will
cm.
extend by, it will extend by 4 cm. 2 centimeter for every 10 gram. I think Dina was the one that got this wrong, right? Every 10 gram, they are going to extend by 2 cm. So because there is a 20 gram over here, so it will extend by 4. Apalagi kalau dia dalam series. And so they will experience the extension on its own. What about this? How much is the extension for this?
8.
8.
It will be 8 cm. So the total stretch should be 12 cm lah. Okay, total stretch means jumlah pemanjangan, bukan jumlah panjang. Saya tidak mau tahu berapa panjang asal. I just want to know how much dia akan extend sahaja. Okay, now why don't you try B? How much is the extension here?
5.
10.
5. 5 or 10?
10.
No, 10. Some say 5, some say 10. What do the rest of you think? Find the total stretch. Okay, let's consider this. 50 grams means dia akan extend berapa banyak? Dia akan extend 10 cm bahkan. But because it's in parallel, kan, is the extension dikongsi atau the extension dirasai bersama?
Dirasai bersama.
Gede-gede.
Parallel or dikongsi bersamakah atau dirasai bersama?
Dikongsi.
Sorry,
Sama.
mungkin saya punya bahasa yang buruk ini kan, dirasai bersama. Actually it's dikongsi lah. Sama bahkan sebenarnya dikongsi dan dirasai bersama. Okay, fine. Yeah, so actually the extension is only 5 cm lah. Okay, right. Let's take a look at this situation. 40 grams. This is spring A, this is spring B. I want to know what is the total extension only. Okay, try to figure this out. When you have your final answer, just tell me what your final answer is.
Twelve.
12. Okay, somebody, Mordecai said 12.
12.
Anybody? Okay, Melanie also said 12.
12.
12, huh? Okay, let's double check. A should extend by how much?
8.
8.
A should extend by 8. B, setiap satu, B akan extend by 16. No. 4 cm for every 10. B wall. 4 cm for every 10. So dia akan extend 16 bahkan. Tapi because dikongsi bersama, so each one will get 8 and 8. No meh? Saya silap kan?
Ngam lah tu. Jawapan dia 16 lah, bukan 12.
That's why. So itulah saya macam mana kau dapat ni 12 ni. Maybe kamu terlupa bahawa ini adalah B. Spring B and spring A is different. Okay, so it should be 16. Okay, B actually should extend 16, but because it's parallel, dia adalah dikongsi. Okay, the extension will be shared equally lah. Okay, so be very careful with this. Okay, elastic potential energy, actually I can just leave this here because you can calculate this yourself. Just make sure that you change the unit to meters. Okay, very important over here lah. Okay, ini kamu tahu sudah. Can you tell me what to do here? If I give you a graph and I ask you to calculate the potential energy, what are you supposed to count?
Area.
Okay, area where?
Below.
Under the
Area under graph.
Area under the graph. Don't calculate the whole square, please. Okay, so yeah, anyway. This one no need. Okay, this is a normal question. Okay, ini sama si cakap. Okay, so let's say for example, this is the original spring. Original length of string is 14. The spring constant is 200 newtons per meter. What is the symbol for spring constant?
N
K.
per M.
Okay. M. Hello, symbol, not unit. Symbol for this one is K. Okay, now this is exactly what I mean. Take a look at this. The original length of the spring is 14 cm, but the spring constant is Newton per meter. Okay, this is a very, very, very big giveaway. You have to change the spring length to meters. Okay, in order for you to answer this question. Okay, very, very careful because the spring constant kamu pakai adalah Newton per meter. Okay, so 14 cm change to meter will be 0.14 meter, original length lah. Okay, then when you compress the spring, dia akan menjadi 10 cm. Okay, which means what is my extension?
4 cm.
4 cm alias
0.04 meter.
okay, 0.04 meter.
Meter.
So can you calculate the potential energy? What formula do we use?
1/2 F times X.
Do we have F?
1/2 kx square.
We use kx squared sebab kamu diberi K. If you're not given F, then use the other formula. That's why there's two formulas lah. Okay, so this will give us you can use this also lah, but you will get 0.16 joule. And then suddenly question B is calculate the maximum velocity after the compression force on the spring is removed. Okay, this requires us to understand something that you discussed masa di form 3 dulu lah. When you push this in, you're going to get all this elastic potential energy. Okay, elastic potential energy. Tapi bila kamu lepaskan, semua elastic potential energy akan berubah menjadi what kind of energy? Anybody? Okay, it will change to kinetic energy. So, our starting point for this question will be the elastic potential energy equals to the kinetic energy. Who remembers the formula for kinetic energy?
1/2 mv square.
Okay, 1/2 mv squared. And our elastic potential energy is 0.16 lah. Okay, so this is what we call the principle of conservation of energy. Okay, in this case, when you push the ball in, okay, it is going to simpan the elastic potential energy because it is in the spring. Tapi bila kamu lepaskan itu bola, the bola will fly bahkan. Asalkan the bola flies kan, that's kinetic energy. So we assume that all the elastic potential energy inside here dipindahkan ke dalam bola ini supaya dia boleh terbang jauh. And that's why there's this velocity question over here lah. So when you calculate this, okay, you will get 0.16 equals to half mv squared and you will get 5.66. Dengan syarat your m, please change 10 grams. Make sure you change it to kilograms. Okay, ini adalah perkara biasa lah. This is a very common question, people. From elastic potential energy terus tukar pergi kinetic energy. Okay, so please take note of this lah.